This is part one of 3 lectures on the numbering system for binary, hexadecimal, and octal numbering systems. Numbering systems are very important in digital because they represent how computers and digital systems actually work with numbers, since they really don't know decimal numbers. So you should have already looked through the actual lecture notes and read those and kind of got a pretty decent feel for how binary numbers work. I want to show you some examples and how to convert them by hand in this lecture. So let's take the number 10101 and let's convert that over to a decimal number. And one of the first things you need to do is put that into a chart. And the chart is formed by taking the base, which in this case is a 2, since it's binary. Binary is a base 2 numbering system, and taking that to the 0 power, to the 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. And that will create a chart starting at 1, and anything to the 0 power is always 1. So you've got 1, and then 2, and 4, then 8, and then 16. So if you start with a 1 and you double it each time, in other words, you multiply it times the base, it's 1 times 2 equals 2, 2 times 2 equals 4, 2 times 4 equals 8, and 2 times 8 equals 16. And you can keep going. 2 times 16 is 32, 2 times 32 is 64, and on as many as you need, as long as the binary number is that you need to do. Once you get that chart made out, then you need to put your binary number underneath of it. And you can see we just placed, starting at the least significant side, which is this side down here. Starting here, do 1, 0, 1, 0, 1. That way your least significant bit will always line up on the smallest side, and it will go only as far as it needs to go. Once you do that, multiply the ones that have 1s underneath of them. Now you could do the 0s as well, but since you're adding them up when you convert them, there's no reason to. I show them here, but you don't really need to do the ones that have 0s. So we really could have left out this 0 right here and this 0 right here, because there was really no reason to do those. We could have just had the 16 plus 4 plus 1 and been done with it, equals 21, and that's all we really needed to do. So the binary number 10101 equals 21 in decimal. Here's another one, and let me show you how I usually convert numbers if I have them on paper. If I have the number 1011, and that's a base 2, a binary number, I start out with my chart, but I just write my chart like right over top of this. So you got 1, double that, 2, 2 times 2 is 4, 2 times 4 is 8, and then just add up the numbers that have 1s underneath them. So it's 8 plus 2 plus 1, and you can generally do those in your head. So 8, 9, 10, 11. So that equals 11 in base 10, which is a decimal number. So this is generally how I do it when I'm working them out on paper, and I'll show you the actual chart and everything on the next few slides, but that's how I generally do it when I'm working them out. There's the chart we created, 1, 2, 4, 8, 16. Put the binary number underneath of them. You notice I really didn't need the 16, but since I already had it, I went ahead and used it. 1 times 8 is 8, 1 times 2 is 2, and 1 times 1 is 1. Add up 8 plus 2 plus 1, you get 11. So here's some practice problems for you, and if you get these, work them out on paper, work them out in your head, whatever you want to do, and write them down and check your answers. I'll pause the video here real quick for you, and hit pause on your remote or whatever, and work these out, and then come back and I'll show you the answers. Okay, here's the answers, and you'll notice that I gave you the actual numbers that you added up to get the answer. These are the answers right here. But over here I kind of gave you what you should have added up to get that. So this is 8, and this is 16, this is 1, 2, 4, 8, 16. You would have added just the 16 and the 1 together, and this one's a 1, and 16, and 32. So those kind of give you an idea of what you need to add together. If you didn't get those answers, maybe go back and work them out again. The most common mistake most people make when they're doing this is they don't start out with a 1. Always start out with a 1 right there. It's real easy to start with a 0 because we're used to counting. And you may also do like 1, 2, 4, and then start counting in like by twos. 1, 2, 4, 8, I mean 6, 8. You know, don't do that. It's 1, 2, 4. You're doubling it each time. So there is no 6 in there. So don't start at 0 and make sure you double it each time. Don't just count by twos. There's two methods of converting from decimal to binary, and the sum of weights method is really for a small number, and successive division is larger numbers. And we're going to work out the same number using both methods, so you can kind of see what's related and what's involved in converting those. So the first step in the sum of weights method is to actually create a chart. And you start out creating the chart with just a 1, 2, 4, 8, 16, 32. Just double it each time. And since our number here is 57, we're only really going to go up as high as what we need to go. So in reality, I didn't need to go to the 64. Once I went above the number we're trying to convert, I could have just stopped. So once you double 32 to 64, so I don't really need 64. I could have started there, but I went ahead and showed you just so you would understand that it's not needed. So the first thing you want to look at is you want to say, can we subtract 64 from 57? In other words, we're taking this number and subtracting it from our number. Well, unless you want a negative number, you really can't subtract 64 from 57. So we're going to put a 0 saying no or false. No, we cannot do that. And go to the next number. Next, we're going to do a 32. Can we take 32 from 57? Sure, we can take 57 minus 32. So put a 1 there. Yes, we could subtract it. And subtract it, and we get 25. 25 is now going to be the next number we're going to subtract. So you're going to look at it and say, can we subtract 16 from 25? Yeah, we can subtract 16 from 25. So you're going to put a 1 there, and you're left with a 9. The next thing we're going to look at is, can you subtract an 8 from 9? Sure, you can subtract 8 from 9. So you put a 1 there, you get 1 left over, 9 minus 8. Can we take 4 from 1? No, so put a 0. Can we take up 2 from 1? Nope, no, I didn't have a positive number. Can we take 1 from 1? Yes, we can take 1 from 1, so put a 1 there. So the binary number 101111 is equivalent to 57. So 100111 is 57 in decimal. Now that's using the sum of weights method. Let's do the successive division. Again, successive division is really for bigger numbers, but we're going to use 57, which may be easier maybe to do it with 57. So what you're going to do is you're going to take the base, whatever your number is, you're going to divide it by whatever base you're converting it to. So since we're going to a binary, which is a base 2 number, we're going to take 57 divided by 2. So if you take 57 divided by 2, you actually end up with a 28 with a remainder of 1. In all reality, you end up with 28.5. If you take that 0.5 times your base, right, half of your base, you get a remainder of 1. That's your remainder. And it really helps out later on when we get into other numbering systems to know that that's how you get the remainder, is taking your base times whatever decimal parts you get. That's your remainder. So for binary, it's pretty straightforward, but for later on, you almost need it. Okay, now we pull down the 28. 28 divided by 2 equals 14. No remainder, no decimal place. Next, we're going to pull the 14 down. 14 divided by 2 equals 7 with no remainder. There's no decimal. Pull the 7 down. 7 divided by 2 equals 3.5. That 0.5 tells you that there's a remainder of 1. Pull the 3 down. 3 divided by 2 equals 1 with a remainder of 1, 1.5. So it's a remainder of 1. And now pull the 1 down, and you're left with 1 divided by 2, which is actual 0.5. But once your whole number there equals 0, stop. There is no more to do. So that 0.5 tells you there's still a remainder. Now, the way you look at this is always your most significant bit. And if you remember from the lecture notes, that's how we laid them out. And this is your least significant bit. And if you kind of think of it as this is a building, and it's always going to fall that way. So the top is always going to fall to the right-hand side of the equation. you're left with 111,001. So the top always falls to the right. Okay. Now, give you some practice problems. Pause the video, work them out, and then come back and I'll show you the answers. Okay, here's the answers, and I didn't go through how to work them out, but if you have any problems working these out, just try to go back through and watch the video again and read the lecture notes again before you do that, and try to work them out again. Maybe you just misdivided, maybe you didn't do a remainder correctly. Usually it's something small that you missed, and just try to work it out. If you still can't get it, just contact me and I'll help you out.